Hello students, myself Swapnil Sir and welcome to yet another video on our vector chapter. Already we have started lecture series on a vector chapter. Plenty of the videos already uploaded based on the vector chapter. If you wanted to see this video, you may do check in my playlist. So in my today's video, I'm gonna explain to you all vector chapter as part of the recap only, and after that we will go for some of the previous year question from the board exam question paper. So already similar videos I have uploaded on vector chapter, complete lecture series, previous year question along with the detailed topic explanation. You can find all these things in my playlist. Okay. So in my today's video, we'll go for a detailed understanding of a vector chapter first as a part of a recap, and then at the end we will move for some of the previous year question. Okay, because as board exam is coming closer, so we need to be very much familiar with this previous type year questions. Okay, so first of all, what we do? First of all, we go for some of the basic concept for understanding, and then we at the end we will move for some of the previous year question. Okay. Okay, now let's start our today's video. Okay, so in our vector chapter we have learned coplanarity of vector, okay, types of the vector, direction cosine, direction ratios, section formula for internal division, section formula for external division. Okay, if vectors are coplanar, then how we can define this vector? All these things we have learned all detail in our previous lecture. Okay. So we will go for some of the recap of these points, okay, and at the end we will solve some of the examples. Okay. So in our vector chapter, already you all are familiar with the condition for coplanarity. Okay, if the two vectors are coplanar, we know that we can write this vector as a one vector which is equal to scalar multiple of some another vector. Okay. So when we have coplanar vector, so actually what is meant by coplanar vector? The vector which are parallel to each other, or the vector which are along with each other. Okay, so we consider this one as the coplanar vector. Okay, so all these things we needed here in a further subsequent examples. Okay, now if the two vectors are collinear, okay, now let me explain some of the concept here. If two vectors are collinear, okay, if we have two vectors are collinear, then one vector can be written as a scalar multiple of another vector. Okay, so we can write a position vector A bar can be written as scalar multiples. I consider here a scalar as a T into position vector B bar. Okay, this is the condition for collinearity. Okay, collinearity condition for our vectors. Okay, so if vectors are coplanar, that means if these all vectors are lies in a same plane, for defining this vector we write A bar dot B bar cross C bar as in the form of a determinant, and we find the product for these vectors. Okay, so this one is the condition for coplanarity of vector. Now subsequently the section formula for internal division, very much important for your upcoming board exam, as a section formula for internal division or section formula for external division, both are important for our upcoming board exam. Okay, for internal division, we write, okay, so we write, if we have ratio for internal division like m as to n, position vector exists there A bar B bar, okay, then we write it's a formula for internal division as a m A bar plus n B bar upon m plus n as the section formula for internal division. Okay, now next section formula for external division. Okay, section formula for external division. Now external division means the point which divide our line segment externally. Okay, internal means the point which divides our line segment internally. Okay, so we have segment A here, then the point which divide here in the middle, so we consider it as the internal division. If you have a line here, the point which divide outside of our line, okay, line segment, so we consider it as the external division. Okay, so as per our condition, we take it as the section formula for internal division and section formula for external division. Okay, so after that, all these points are very much important here. Okay, so I'm expecting that you all have understood these are the basic concept. We don't have much concept in a vector. Okay, there are some sort of very much important concept. We just have to focus only of them. Okay, now let's start our today's lecture with some of the example from previous year board exam question paper. Okay, because we focus only on the previous year questions. Okay, so here in my question, we have given A bar, B bar, C bar. These three are the position vector. Okay, so we have given three position vector. First position vector, it says that A bar, which is equal to, let me write the position vector, I cap plus 2j cap. Okay, I cap plus 2j cap. After position vector B bar, which can be written as, so given in our example, minus 2 I cap, minus 2 times I cap plus j cap. Okay, position vector B bar given. Position vector C bar, it says that 4 I cap plus 3 j cap, 4 times I cap plus 3 times j cap. Okay, these three position vectors are given. Okay, and we have to find out the value for x and we have to find out the value for y using the condition. One more condition we have given. The condition, it says that C bar, which is equal to x into A bar plus y into B bar. Okay, so what the actual of this condition says here, we can write position vector C bar is in the linear combination of x and y. Okay, x and y with respect to position vector A bar and position vector B bar. Okay, so this one is the linear combination for position vector C bar. Okay, so position vector C bar, which is a linear combination for x into A bar plus y into B bar, and by using this linear combination, we have to define the value for x and the value for y. Okay, these two value we have to define over here. Okay, let's go for the defining the value for x and y. Okay, what we do? We just substitute all these position vector in our C bar, which is equal to x A bar plus y B bar. Okay. Okay, so we'll go for the substitution of the value. So what we have, C bar here, 4 times I cap, 4 times I cap plus 3 times j cap. Okay, now as we have the I cap, j cap and k cap are these three present over here, but we don't have present here k cap. Okay, so in such a case, what we do, we add a k cap here. Okay, 0 times k cap. So as we know that when we multiply 0 to any number, it's like a meaningless. Okay, that means 0 times k cap, it is like nothing. So I have added that 0 times k cap here as the position vector of C bar. Okay, 4 I cap plus 3 j cap plus 0 k cap. Okay, this is the value for position vector C bar. Okay, so I am just substituting all these values in our formula. Okay, we don't have anything different here. I'm just substituting all these values. C bar, which is equal to x multiplied by. Okay, so as we don't have value for x, so keep that value as it is. Okay, we cannot do anything with that x because we have to find this value later on. Okay, x into A bar, write down the value for A bar here, I bar, I cap plus 2j cap. Okay, I cap plus 2j cap, I cap plus 2j cap plus, now see that also we don't have the k here. Okay, so what do we do for this k? We take a 0 times k cap. Okay, so this one is the complete values for I, j and k plus next we have y times b bar. Okay, so keep that y as it is. The value for b bar here, now see that the value for b bar minus 2 times I cap plus j cap. Okay, also similarly we don't have the value for k. Okay, take it as the 0. Okay, minus 2 times I cap, minus 2 times I cap plus j cap plus 0 times k cap. Okay, we have these values present here for value of c bar. Okay, so c bar can be written as x a bar plus y b bar. Okay, yes. Now let's go for finding the values. As we have one side in the form of I cap, j cap, k cap, so to compare both of the side, what we do, we try to take another side, or we try to convert another side in the form of I cap, j cap and k cap. Okay, now convert all these variable in this form, I cap, j cap, k cap. Now what we do for this, multiply x under bracket, multiply y under bracket, and take I common, j common, k cap, k common. Okay, so we'll get the x into I cap plus 2x j cap. Okay, plus x into 0 into k cap. Okay, so no need to write, but let me write, let we go for this one. Okay, let it be. Now let's go for the next part here. Minus 2 times y into I cap. Okay, plus y into j cap plus 0 into y into k cap. Okay, this is just a multiplication of x under bracket here. Okay, nothing I done here extra. Yes, so what we do here, take I cap common from the variable. Okay, like we have x minus 2y in x I cap minus 2y into I cap, so take I cap common, so we'll get the x minus 2y. Okay, so x minus 2y, out of the bracket we will get the I cap. Okay, so out of the bracket here I cap. Similarly, plus, so I done it for I cap. Similarly, we can go for the j cap too. Okay, yes, j cap, for the j cap we have 2x into j cap, so 2x j cap common, plus y into j cap, so plus y, and j cap common. Okay, yes, and plus already we have 0 times k cap into 0 times k cap. We don't have to take that 0 times k cap. Okay, so forget about the 0 times k cap. In this situation we do not need the 0 times k cap, whereas we don't have k cap to the value for our position vector c bar. Okay, that's why I did not take on these values here. Okay, yes, so what we compare with the 4 times I cap plus 3 times j cap. Okay, now what we do, we compare I cap variable with the I cap variable, j cap variable with the j cap variable. Okay, compare I with I, j with the j. Okay, so we will get the 4 I cap which is equal to x minus 2y into I cap. That means we get the value for x minus 2y which is equal to 4. Okay, and then 2x plus y which is equal to 3. 2x plus y which is equal to 3. Okay, now see that we got the two different polynomial equation. Okay, so if you are going to calculate the value for x and y by solving this one, so you will get the required answer. Okay, so we want only the value for x and y. Now subsequent part, it is quite easier, just need to define the value for x and y. Okay, so let's go for the calculating the values. Okay, so what we do, we multiply 2 to the first equation, so we'll get the 2x minus 4y which is equal to 8. What I have done, I multiplied 2 to our first equation. Why I have multiplied? Because we want second equation and first equation, their variable same. Okay, then we can get the answer. So let's write the next equation, 2x plus y which is equal to 3. Okay, and subtract both of them. Okay, so I have multiplied here by equation here by 2. Okay, and then I have subtracted both of them. So 2x minus 2x can be, it will be the value 0. Okay, minus 4y plus y, it comes minus 3y which is equal to 8 minus 3, it gives us 5. Okay, so minus 4y plus y which is a minus 3y which is equal to 8 minus 3 which gives us the value 5. Okay, then y, it can be written as 5 divided by negative of 5 divided by 3. Okay, so y, I got the value for y, which is a negative of 5 divided by 2. Okay, yes, what we have here, x minus 2y, yes, which is equal to 4, and 2x plus y which is equal to 3. Okay, so what we do here, to multiply 2x minus 4y which is equal to okay, 2x minus 4y which is equal to 8, okay, and 2x plus y which is equal to 3, okay. So after subtracting 2x will be 0, minus 4y minus y, okay, it is not like that, minus 4y minus y it is there, okay. So I by mistakenly I did not consider that negative sign, okay. So plus minus it gives a minus, okay. So this one goes to the minus. So minus 4y minus y, it gives us minus 5y, okay. So which is a minus 5y. So be careful about your calculation. So by mistakenly I taken here another sign, okay. So you all have to be very much careful, because negative positive it goes to the negative, okay. So 2x minus 2x 0. So minus 4y plus minus minus y which is a minus 5y, okay. So minus 5y which is equal to 5, then y which is equal to negative of 5 divided by 5, okay. Then it gives us y which is equal to minus 1, okay. So see that I got the value for y which is a minus 1, okay. So I've got the value for y which is equal to minus 1. Similarly, go for the value of x. If I'm gonna substitute that y in one of the equation, we'll get the value for x, okay. Now substitute anywhere. So I consider here x minus 2y which is equal to 4, okay. X minus 2y which is equal to 4. Substitute y minus 1. So x minus 2 into minus 1 which is equal to 4, okay. X minus minus plus, x plus 2 which is equal to 4, and x which is equal to 4 minus 2, and then we get the x which is equal to 2, okay. So we have the value y which is equal to minus 1 and x which is equal to 2, which is here, okay. This is the value for x, this is the value for y, okay. So I hope you all have understood. Nothing is difficult here. In our question, what we have to define? First of all, we have to define our variable in the form of a linear combination, okay. And once we get the linear combination, then go for comparing their corresponding I cap, j cap and k cap. You will get the required answer, okay. So I hope you all have understood this solution. Let's go for the next solution. And if you want the solution for our example, you do check in my description section, okay. You will get the complete solution file there, okay. So I have already uploaded these files, okay. You do check it, these values PDF in our description box, okay. So without let's go for the next example. Next example, which is from October 2015 board exam, okay. It asks for 4 marks, okay, in October 2015. And question it says that express minus I cap minus 3j cap plus 4k cap as a linear combination of a vector, first vector, second vector and third vector. So we have 3 vectors. We have to write the linear combination of one vector which is equal to some another vector, okay. Now see that if we have the vector, if we have the vector c, we can write the linear combination of this vector with another vector as x into a bar plus y into b bar, okay. X into a bar plus y into b bar plus w into k bar, okay. So you may take any other variable, okay. This is the linear combination of a vector, position vector a bar, b bar, k bar with respect to position vector c bar, okay. And x, y, w are the variable which we have here, okay. So using this condition, we have to solve this example, okay. So let me write what we have given in our question. So in our question, we have given minus I cap minus 3j cap, okay, plus 4k cap, okay. This one is a one position vector, okay. So we have to write that position vector in the linear combination of a remaining 3 position vector. So what I do, I consider this one as a which is equal to d, okay. This one I will consider here d as a position vector, okay. I just named it as a d bar, okay, position vector d bar. Similarly, go for the next. We have given 2 times I cap plus j cap minus 4k cap, okay. This one is our first position vector. I consider here as a bar, okay. Let's go for the second position vector. 2 times I cap minus j cap plus 3 times k cap, okay, which is equal to consider second position vector as a b bar, okay. So I consider here as a second position vector b bar, okay. This one is a position vector b bar. Now similarly we have third position vector 3i plus j minus 2k. 3i plus j minus 2k. Okay, 3i cap plus j cap minus 2k cap, consider it as the third position vector c bar. Okay, now what we have given, first position vector can be written as the linear combination of a remaining three position vector. Okay, so how can we write the first position vector in the linear combination of a three position vector? Now see that d bar, which is equal to x into a bar plus y into b bar plus z into c bar. Okay, so we write it is as the d bar, which is equal to x a bar plus y b bar plus z c bar, and then we are going to find out the value for x a, y b, x, y, z, and we will revert the value for x, y, z in our given linear combination. Okay, so how can I write here the linear combination? Okay, I will explain the linear combination of a position vector with respect to our considered variable. Okay, yes, now we can see that we have to write a d bar, that means here minus I minus 3j plus 4k in the linear combination of remaining 3 1. Okay, so I written d bar here, which is equal to, okay, linear combination of first, second and third. Okay, that means linear combination of x into a bar plus y into b bar plus consider it as the z into c bar. Okay, so I consider here d bar as a x a bar plus y b bar plus z c bar. Now what we do, replace all the values for d bar, a bar, b bar and c bar here in our linear combination, and then find out the value for x, y and z. Then find out the value for x, y, z and revert back these values in our linear combination. Okay, so there are several other methods for finding the value of x, y, z. As we can solve the polynomial, there are so many methods. Okay, I will explain how to solve this one, but first of all we will go for the linear combination of these vectors. Okay, and once we take the linear combination, we come to know the separate equations for our variables. Okay, put all these values here. Okay, so what we have here, d bar, so write down d bar, which is a minus I cap minus 3 times j cap plus 4 times k cap. Okay, this one is our d bar, okay, which can be written as x into a bar. A bar, what we have here, 2i plus j minus 4k. Okay, 2i cap plus j cap minus 4 times k cap. Okay, this one is our a bar. Okay, 2i cap plus j cap minus 4k cap plus after that y into b bar. What is the value for b bar? 2i minus j plus 3k. Okay, 2i minus j plus 3k. Okay, 2i minus j plus 3k plus c bar. Okay, c bar under bracket, what we have here, sorry, value for z c bar, we have z c bar, so keep z as it is, as we want the value for z here, z c bar. Okay, let me whip this out. Okay, so z into c bar, what is the value for c bar? 3i plus j minus 2k, 3i plus j minus 2k. Okay, 3i cap plus j cap minus 2k cap. So what I have done, basically I have written here d bar, which is equal to x into a bar plus y into b bar plus z into c bar as the position vector for our given linear combination. Okay, yes, what we do here now, we one side it represent the values for I cap, j cap, k cap. Similarly, go for the another side and convert all these equation in the form of I cap, j cap, k cap. So it is easier to compare both of the sides. Okay, so keep that first side as it is. So in our second side, what we do, go for under bracket multiplication of x, y and z. Okay, then take I cap, j cap, k cap common from here. That means 2x I cap plus x j cap, okay, minus 4x k cap. Okay, plus 2y I cap, 2y I cap minus y j cap plus 3y k cap. Okay, second one. After that, let's go for the third. 3z I cap, 3z I cap plus z times j cap minus 2z k cap, 2z into k cap, okay, 2z into k cap. This one is our under bracket multiplication, okay. Take I common together, j common together, and k common together, okay. Yes, so what we have another side here, keep as it is, okay, minus I cap minus 3j cap, okay, minus I cap minus 3j cap plus 4 times k cap. Keep as it is. What I have done, just replace the values here because questions are quite big, they are time taking, okay. Yes, which is equal to 2x. Now see that first we have here 2x, again 2y, and again 3z, okay. So take the I common from these three brackets. What we will get it here, 2x plus 2y, 2x plus 2y plus 3z, okay, 3 times z into I cap out from here, okay. After that xj minus yj plus zj, okay. Take j common from here plus j common from here, okay. Yes, now take the j from the one side here, so that will be the suitable for your plus j. I will take here as a plus j common. So under bracket it what will remain here, x plus x minus y, x minus y plus z, okay. So x minus y plus z into j cap, okay. So x minus y plus z into j cap out of the bracket, okay. So similarly for k cap, do it for the k cap, okay. So minus 4x k cap, after that 3y k cap and minus 2z k cap, okay. Take the k cap common, okay. So we left here the value minus 4x, after that k cap plus 3y minus 4x plus 3y, after that minus 2z, okay, into k cap out of the bracket, which is equal to 0, okay. No, not equal to 0 because we have other side there, so don't take it 0. Yes, now see that I have written linear combination of a 3 vector as another one vector, okay. And now as we can observe here, it seems like that first variable I cap here with a multiplication of bracket into I cap. Similarly, second position, second vector, it is j cap, it is the equation of a j cap, and similarly k cap here. Now compare corresponding variables from the both of the side, you will get the required I cap, j cap, k cap equations, okay. So we can see here minus I cap, which is equal to 2x plus 2y plus 3z into I cap, okay. That means we get the minus 1, which is equal to 2x plus 2y plus 3z, okay. This one is our first equation, minus 1, which is equal to 2x plus 2y plus 3z, okay. Now let's go for the minus 3j cap, okay. So minus 3, which is equal to x minus y plus z, okay. Minus 3, which is equal to x minus y plus z. So we get the minus 3, which is equal to x minus y plus z, okay. And plus 4, which is equal to, we can write third equation as plus 4, which is equal to minus 4 plus 3y minus 2z, minus 4, let me write this one, okay. So minus 4 plus 3y minus 4x, okay, minus 4x plus 3y minus 2z, okay. Okay, which is equal to the value for our first equation here, second equation and third equation, okay. This one is our first equation, okay. This one is our second equation, and this one is our third equation, okay. Now what we do, go for the value of a minus, solving this equation further, okay. Now as we have three different equation, okay, and using the three different equation, we want the value for x, y, z, okay. So if we come under two different equations, so it is the easier to solve one by another, okay. So we can add them, subtract them, or you may find the value which is satisfying equation one, then we substitute into the second, so we get the required option. But in now this condition, what we have here, we have three equation. Okay, now for solving three different linear equation, okay, in the variable of x, y, z, we use a Cramer's rule from the determinant. Okay, Cramer's rule from the determinant. So you all need to know what is the Cramer's rule for the determinant. Okay, yes, so if you come to understand the Cramer's rule for determinant, then next further part, it is just an calculation based. Okay, so I will explain to you all what is the Cramer's rule for the determinant. First of all, understand the Cramer's rule for determinant, and then we will go for the solving our equations here. Okay, now see that, let me write the equation separately because we don't have sufficient space here. Okay, so here we can see minus 1 plus 2x plus 2y plus 3z, minus 1 which is equal to 2x plus 2y plus 3z. Okay, so our first equation, minus 1 which is equal to 2x plus 2y plus 3 times z. Okay, this one is our first linear equation. We got it by using linear combinations. Okay, minus 1 which is equal to 2x plus 2y plus 3z. Next equation, minus 3 which is equal to x minus y plus z. Okay, minus 3 which is equal to x, let me see first again, x minus y plus z. Okay, x minus y plus z. Okay, this is our second linear equation, minus 3 which is equal to x minus y plus z. Okay, yes, and fourth equation, 4 which is equal to minus 4x plus 3y minus 2z. Okay, minus 4x plus 4 which is equal to minus 4x plus 3y minus 2z plus 3y minus 2 times z. Okay, so now see that we have three different linear equations. Okay, so as we want the value for x, y, z, we convert into the determinant. Okay, so value for determinant we can write here. Okay, let me change the color. So we will go for finding the determinant first. Determinant, we can write the coefficient for x, y, z, x, y, z and x, y, z. Okay, so first entire column it goes for coefficient of x, second entire column it goes for coefficient of y, and similarly we get for third column. Okay, so first column it is the coefficient for x which gives a 2, 1, minus 4. Okay, second entire column 2, minus 1 and 3. Okay, and third entire column 3, 1, 3, 1 and minus 2. Okay, this is the value for our determinant d. Okay, and the another side of that determinant, it represent as a minus 1, minus 3 and 4. Okay, so consider this one as a p. Okay, so we do have the value for a d and we do have the value for p. Okay, so I consider this p just as an variable. Okay, I named it as a p because to go for the pronunciation again and again it will be time taking. So I consider this here as a p. Okay, now what we do, first of all go for finding the determinant. Okay, so I'm not gonna explain to you all how to find the determinant. If you wanted to see how can we find the determinant, so you may check it into my playlist. Okay, already the video is already uploaded there for finding the determinant. Okay, yes, now value for determinant, go for directly value for determinant. What we do here, we take with respect to 2 this 2 by 2 determinant, minus 2 with respect to this 2 by 2 determinant, and plus 3 with respect to this 2 by 2 determinant. Okay, yes, and you have to find it out determinant. Okay, so you will get the determinant as a minus 9. Okay, as I have found earlier, which is not equal to 0. Okay, so we got the value for a determinant d which is a minus 9, which is not equal to 0. Okay, so I'm explaining to you all here Cramer's rule. Okay, using Cramer's rule we are dealing with the value of x, y, z. Okay, I got the value for determinant d as a minus 9. Similarly go for the value of a d using d x, y, z. Okay, so we want the value for x. For finding the value of x, let me write how can we find the value of x. X can be written as dx divided by d. Again, value for y can be written as a dy divided by d, and value for z can be written as dz divided by d. Okay, x is a dx by d, y dy by d, z dz by d. Okay, now replace the all values here. Yes, okay, So dx, so how can we find the dx? As we know that determinant d gives us the value -9. So this d and this one is d. These are the all these value we do have here as a -9. Okay, determinant -9. Now our task is to find out the value for dx, dy and dz. Okay, so for finding the value of a dx, we know that in our determinant, okay, in our determinant, what we do, we replace our first column for x variable as a p. Okay, first column for x variable we replace as a p. So replace it now, -1, -3, 4. Okay, this one is the value for dx. Okay, x value for p I replace here. Okay, remaining two values keep as it is, 2, 3. Okay, -1, 1, 3, -2. Okay, yes, this one is our value for a dx. Okay, I'm expecting that you all have understood how can we find the value for dx. Okay, similarly, as you found the value for d, go for the finding the value for determinant dx. Okay, so I'm going to write the answer for dx as I found earlier. Okay, so dx, the value for dx which gives us -18. Okay, value for dx which gives us -18. Okay, so go for the finding determinant. Okay, so take -1 common, this 2 by 2 determinant with respect to this, -2 with respect to this 2 by 2 determinant, and a +3 with respect to +3, we have this 2 by 2 determinant. Okay, go for finding the determinant, you will get the dx as a -18. Okay, now similarly find out the value for dy and dz. Okay, so as we have done earlier, we replaced x as a p. Okay, in the place of x we replaced the p. Okay, similarly replace y as a p now. Okay, in our d. Okay, so remaining 2, 1, -4, it will remain as it is. Okay, then 3, 1, -2, 3, 1, -2. Okay, first entire column and third entire column, it will remain same. Okay, now in the place of a variable of y, okay, these are the columns. Second column we have here, which is completely values from the coefficient of y. So replace for dy as a p. Okay, so we will replace -1, -3 and 4. Okay, as the value for dy. Okay, so if you're going to find out the value, you will get the answer for dy, which is also -18. Okay, we will get the value for dy as a -18. Okay, yes. Now similarly go for finding the dz. I'm not gonna find that determinant here because it is a time taking, so this one is the easier. Let's go for the dz. Okay, dz is similar like our previous one. We go for the dz, we replace in the place of a coefficient of a z as the value of a p. Okay, keep another column same, because we have to keep the column from this d. Okay, don't go for the changing dx and dy. Okay, yes. Yes, now what we have here, write down the coefficient of x and coefficient of y as it is. So 2, 1, -4, 2, 1, -4 as it is, 2, -1, 3 as it is, -1, 3 as it is. Now for the finding of value of a dz, replace coefficient of a z by p. Okay, instead of values of a z, we replace by p. Okay, so which is a -1, -3 and 4. So this is the value for our dz. So it is similar like a previous determinant. Okay, so you have to go for finding the value of a determinant. You will get the value for dz as a 27. Okay, now we want the value for x, y, z. For finding the value of x, y, z, we write x which is equal to dx divided by d. Okay, dx divided by d. The value for dx which is a -18, value for d which is a -9. Okay, again similarly y which is equal to dz divided by d. Okay, the value for dz we have here 27, sorry, dy divided by d. Okay, not a dz. We are finding the value for y, so y can be written as dy divided by d. Okay, and z can be written as d times z divided by d. Okay, okay, so value for dy here, substitute here, -18 divided by -9, which is the value for d. Okay, again dz can be written as 27. So already we do have the value for dz and a d here as a -9. Okay, value for d here as a -9. Okay, go for the finding next calculations. Minus minus get cancelled. Okay, 18 by 9 it comes to 2. Okay, again why it is a 2, again 9 3s are 27. Okay, so -3. So value for this one is the value for x, this one is the value for y, and this one is the value for z. Okay, this one is the solution for our x, y, and z, three different variable. Okay, I hope you all have understood how can we find the value for dx, dy, dz or x, y, z using three different linear equations. Okay, so we learned here Cramer's rule for finding the solution. Okay, now see that nothing is difficult here, just the part of a calculation, but you need to be very much careful while solving these examples. Okay, so let's move for the next example. Okay, in our next example we have given 3 points, a -7 4 -2. Okay, a point is given -7 4 -2, point A. Point B given okay, point A given here -7 4 -2, point B given -2 1 0, and a point C which is given 3 -2 2. Okay, so and we have to show that these 3 points are collinear. Okay, and as we know that for finding the collinearity of a collinearity condition for our 3 different position vector. Okay, so we write one position vector is in the scalar multiple of another position vector. Okay, but as we have vertices for line like a b c, so we convert it in the position vector for our line. Okay, okay, so let's consider here a bar, b bar, c bar are the position vector for point a b c. Okay, a bar comma b bar c bar are the position vector, okay, of a comma b and c. Okay, so we have a bar, b bar, c bar are the position vector of capital A, capital B and capital C. Okay, so write down the position vector a bar using capital point A. So we can write it as the, okay, using point A we write a position vector a bar. Okay, we write the position vector a bar using point A, and it can be written as -7 times I cap plus 4 times j cap minus 2 times k cap. Okay, so what I done basically here, I introduce I j cap in our point A. Okay, similarly go for the point B. Okay, from the vertices B or point B we write a position vector b bar, okay, which is equal to -2 times I cap plus 1 times j cap plus 0 times k cap. Okay, that means -2 times I cap, okay, plus 1 times j cap plus 0 times k cap. Okay, 0 times k cap here. Okay, so as we have to complete I j cap, so return 0 times k cap here. Now using vectors vertices C here, okay, we can write a position vector C bar as 3 times I cap minus 2 times j cap. Okay, so 3 times I cap minus 2 times j cap plus 2 times k cap. Okay, so here I have written position vector A bar, position vector B bar and position vector C bar here. Okay, okay, now as we know that these we have to show these points are collinear. Okay, that means we have to show one segment like a position vector AB bar which is some scalar multiple of a position vector BC bar or AC bar. Okay, so this condition we have to prove here. Okay, that means we can write AC bar can be written as some scalar multiple of AB bar. Okay, so let me find first of all the value for AC bar and AB bar. Okay, okay, let's go for the AC bar and AB bar. Okay, for finding the value of AC bar, now see that how can we find the value for AC bar. Okay, Okay, AC bar means we have to subtract a position vector from C bar to position vector from A bar. Okay, so AC bar can be written as C bar minus A bar. Okay, this is the value for AC bar, which is a C bar minus A bar. Okay, now as we have C bar, A bar substituted here, you will get the value for AC bar. Okay, and then go for finding the AB bar and show both of these AC bar and AB bar are scalar multiple of each other. Okay, some scalar multiple. So AC bar can be written as a C bar, so which is a 3 times I cap minus 2 times J cap plus 2 times K cap. Okay, this is the value for C bar minus times A bar. Okay, minus of minus 7i plus 7 times I cap. Okay, plus 7 times I cap minus of plus 4 J cap. We write a minus 4 times J cap. Okay, and minus of minus 2 times K cap, we write it as the 2 times K cap. Okay, so because negative of A bar there. Okay, negative of position vector A bar. So I just multiply negative sign under bracket here. Okay, go for the calculation. So AC bar can be written as a 3i plus 7i, can be written as a 10 times I cap. Okay, what I am doing here, okay, I'm just trying to add the similar variable coefficient, variable. Okay, so 3i cap plus 7i cap, which is a 10i cap, minus 2j cap minus 4j cap minus 6 times j cap. Okay, plus 2k cap plus 2k cap, we can write 4 times k cap. Okay, yes, so I have written AC bar is equal to 10 I cap minus 6 J cap plus 4 times K cap. Okay, so if you have possible, take some constant from these three of these variables. So AC bar also can be written as, take 2 common, 2 out of the bracket. So 5 times I cap minus 3 times J cap plus 2 times K cap. Okay, this is the value for AC bar. Okay, so I got the first value for AC bar here. Okay, this one is the AC bar, first AC bar. Okay, similarly find out the another variable, another AB bar or AC bar or AB bar or BC bar. Okay, and show that both of these are having some scalar multiplication between them. Okay, now what we do here, we go for finding AB bar. Okay, we go for finding AB bar. Okay, and AB bar can be written as position vector of a B bar minus position vector of A bar. Okay, so what is the position vector of a B bar we have here? So see that B bar, substitute this value here, minus 2 times I cap. Okay, plus J cap. Okay, and plus 0 times K cap, 0 times K cap. Okay, minus of a position vector A bar. Okay, plus 7 times I cap, negative of negative 7 times I cap, we write a positive of 7 times I cap. Okay, so negative of 4 times J cap can be written as negative of 4 times J cap itself, because we are multiplying that negative sign to our position vector B bar. Okay, so negative of 7 times I cap minus 4 times J cap plus 2 times K cap. Okay, so what we do, the similar variable I cap J cap we have here, we are going for addition of them. Okay, so now see that minus 2 times I cap plus 7 times I cap can be written as 5 times I cap. Okay, J cap minus 4 times J cap can be written as minus 3 times J cap. Okay, yes, and 0 times K cap plus 2 times K cap can be written as 2 times K cap, which is the value for AB bar. Okay, so position vector AB bar here. Okay, now what we do here in our next step, we compare AB bar and AC bar here. Okay, so if we come to know that AB bar and AC bar are having some scalar multiple between of them, then we write them as the collinear vector. Okay, yes, now AB bar put which is equal to AC bar. Okay, so AB bar we have here 5 times I cap minus 3 times J cap plus 2 times K cap, which is equal to AC bar 2 times 5 I cap minus 3 times J cap plus 2 times K cap. Okay, yes, so I have written this AB bar which is equal to 2 times 2 times A here. Okay, AC bar as a 2 times this one. Now as we can see that this first this first position vector which is equal to this first position vector. Okay, that means I got this is AB bar can be written as some scalar multiple of AB bar. Okay, that means one vector can be written as some scalar multiple of another vector. Okay, so I have written one vector is in the some scalar multiple of another vector. Okay, that means AB bar and AC bar, whether it is parallel to each other or along line. Okay, and if it is parallel to each other along line, then we say that A bar, comma B bar and C bar are collinear. Okay, we say that these three vectors are collinear. Okay, I'm expecting that you all have understood. Nothing is difficult here. You just need to apply some of the basic concepts. Okay, I hope you all have understood. Let's move for the next example. Okay, so our next example, which is from July 19. Let me see how many. Two. Okay, only two last examples there. Okay. Yes. Now in our next example, we have given the vectors 2i cap minus qj cap plus 3 cap k cap and 4i cap minus 5j cap plus 6k cap are collinear. Okay, so we have given two different vectors and these two vectors are collinear. Okay, and already you are familiar with the meaning of a collinearity. Okay, if two vectors are collinear, that means we write one vector which is the parallel to another vector. Okay, so both of these vectors are coming like that. First vector here, second vector here. Okay, those are the parallel. Okay, so this is the condition for parallel of a two parallel condition for two vector. Or if we get the first vector here, second vector another front here, so we get the two vector, one is vector with along with the another vector. Okay, so this is the parallel collinear vector. Okay, so and we have given 2i cap, okay, minus q times j cap. Okay, minus q times j cap plus 3 times k cap. Okay, 2i cap minus q times j cap plus 3 times k cap, and next position vector 4 times I cap minus 5 times j cap. Okay, plus 6 times k cap. Okay, we have these two position vector. Let's consider one as a bar, another as a b bar. Okay, okay, these two vectors are collinear. Okay, both are collinear. Both are collinear. Okay, vector, both vectors are here collinear. And if we have two vectors are collinear here, then we can write one vector is a scalar multiple of another vector. Okay, if the two vectors are collinear means if they are parallel or along, then we write one vector is scalar multiple of another vector. So we can write a bar which is equal to some scalar multiple of b bar, and that scalar I consider as a t, where t is a scalar. Okay, I consider where t as a scalar. Okay, so t as a scalar. Now put the value for a bar here, 2 times I cap. Okay, what we do here? Okay, so a bar which is equal to t times b bar. Now substitute the values here. Okay, now let me substitute here. A bar can be written as some scalar multiple of another vector b bar. Okay, that is the condition we know for collinearity of a vectors. Okay, now put the a bar, so which is a 2 times I cap, okay, minus q times j cap plus 3 times k cap can be written as first position vector. It can be written as some scalar multiple of another position vector. Now we can write it as the 4 times I cap, okay, minus 5 times j cap plus 6 times k cap. Okay, this one I have written once position vector is a scalar multiple of another. Okay, yes, now let's go for the multiplication of a t under bracket. So we'll get the 2i cap, keep as it is here, minus q times j cap, okay, plus 3 times k cap. Okay, which is equal to 4 multiplied by t into I cap minus 5t. Okay, minus 5 times t j cap, okay, plus 6 times t k cap, okay. Okay, so we compare both of the sides, okay, a similar variable, we take it together, okay. Now we can see that 2 I cap is equal to 40 times I cap, okay. Then we get the 4 times t, which is equal to 2, okay. So we can see here 2I, which is equal to 4 times t, okay. So we can write a bar in some scalar multiple of b bar. That means we can take it as the, okay, we can take 2I cap minus qj cap plus 3k cap is equal to t times 4I cap minus 5j cap plus 6k cap, okay. And both are the vectors are collinear, okay. Both vectors are collinear. Then we can write t, which is equal to 2 by 4, okay. That means we don't have the vector and these vectors are collinear, okay. That means we do not have first vector is a scalar multiple of another vector, or second vector is scalar multiple of first vector, okay. That means we have to choose here the value for a random value for here, okay. So we get the t is equal to 2 by 4, okay. Now first I got the t, which is equal to 2 by 4. Now compare minus q, which is equal to minus 5 times t, okay. Minus qj, that means minus q, which is equal to minus 5 times t, okay. So minus q, which is equal to minus 5 times t there, okay. So what we do, negative negative, take it negative negative, cancel it from both sides. Q, which is equal to, we get the 5 times t, okay. Q, which is equal to 5 times t, and q, which is equal to, value for t is 2 by 4, okay. That means 5 times 2 divided by 4 it is there, okay. 2 by 4, that means we write it as the 1 by 2, okay. That means value for q, I got the value for q, which is 2 1s are 2, 2 2s are 4. That means we got the value for q is 5 by 2, okay. This one is our required answer for q, which is 5 by 2, okay. I'm expecting that you all have understood the value for q, which is 5 by 2. Nothing is difficult here in our question, okay. Question asked in July 2019 board exam for 4 marks, okay. Need to apply only the basic condition for the collinearity of vector, okay, for collinearity of vector. And if two vectors are collinear, that means we write first vector is a scalar multiple of another vector, okay. That's the condition definition we have to apply here. Now let's move for the next question, okay. I am expecting you all have understood everything. Even after, if you found anything difficult, let me know in my comment section. I will come up with the similar videos, okay. Let's move for the next question. So we have a bar, b bar are non-collinear vectors, okay. That means two vectors are there, a bar and b bar, which are the non-collinear. That means they are not parallel or they are not along with the line, okay. So both are the non-collinear. And what we have given, a bar and b bar, both how it is non-collinear, okay. Both are non-collinear, okay. And a c bar given, we have here c bar, which is equal to x minus 2 into a bar plus b bar, okay. So c bar can be written as x minus 2 into a bar plus b bar, and d bar can be written as 2x plus 1 a bar minus b bar, okay. 2x plus a bar minus b bar, okay. And c bar and d bar, we have both are the collinear. Both are the collinear vector, okay. Both are the collinear vector. So these all the condition we have given in our example, okay. And we want the value for x, okay. What we want here, the value for x here. So keep in mind, we have to proceed for the x only. So take the step as we have given in our question, okay. So we know that one vector, it is a scalar multiple of one vector, it is the collinear with another vector. That means we can write one vector, it is the scalar multiple of some another vector, okay. That means we can write c bar, it is the some scalar multiple of d bar, okay. So we can write c bar, which is equal to t times d bar, okay. So why I have written? Because these two vectors are collinear, and if the two vectors are collinear, then we write first vector, which is the scalar multiple of another vector, okay. Yes. Now x c bar, put it here, x minus 2 a bar plus b bar, okay, which is equal to t times d bar. So 2x plus 1 into a bar minus b bar, okay. That means first position vector, which is a scalar multiple as a t with another position vector, okay. Now multiply t under bracket, so we get the next value as a, okay, x minus 2 is there, it is not the c, okay. So we need to be careful with the values, okay. Now let's go for the next. 2x minus 2 into a bar plus b bar. 2x, okay, so we have the value for x minus 2, okay, x minus 2 into a bar plus b bar. So x minus 2 into a bar plus b bar, which is equal to t times d bar, that means t times 2x plus 1, 2x plus 1, 2x plus 1 into a bar, okay, plus minus t times b bar, okay. Now see that I have multiplied that t under bracket here, okay. So once we found here, I have found here the value for 2x minus 2 into a bar plus b bar, which is equal to t times another position vector, okay. Now see that compare the corresponding variable wherever we found same, okay. Now see that x minus 2 a bar can be compared with the t times a 2x plus 1 into a bar, okay. So we write here x minus 2, which is equal to t times 2x plus 1, okay. This is the value for our corresponding variable a bar with the a bar, okay. Similarly, plus b bar, which is equal to minus t times b bar. So this gives us, using second comparison, we write minus t, which is equal to 1, okay. That means it gives a t which is equal to minus 1, okay. T which is equal to minus 1, and we want the value for x, okay. Now what we do, substitute this value back here, okay. So we write x minus 2, which is equal to value for t, which is a negative of 1, okay. So I replace the value of a t as a negative of 1, okay. So x minus 2, which is equal to negative of 1 into 2x plus 1 here, okay. Just need to replace the values, okay, and go for the further calculation. You will get the required answer, okay. So x minus 2, which is equal to minus 2 times x minus 1, okay. So take all these variable to the one side, and proceed with the calculation of x, okay. So x plus 2x, okay. So what I have done, negative 2x to the other side, it uses the positive 2x, okay, which is equal to, take negative 2 here, it comes a positive 2 minus 1, okay. So negative 1, I kept it as it is, okay. X plus 2x, it gives us a 3x, and 2 minus 1, it goes to the 1. So which gives us x, which is equal to 1 by 3 is our required answer, okay. Now see that question, it is the latest question from February 2020 board exam. A question asked for 4 marks. Nothing is there, just need to apply the condition for collinearity, coplanarity, and need to find out the position vector, okay. Once you come to understand the position vector, then subsequent part, I don't think so anything it is difficult, okay. So here in our example, we got the value for x, which is a 1 by 3, okay. Okay, now I am expecting you all have understood everything. If you want this solution, do check in my description box, okay. Let's move for the next. In the last part of my lecture, okay, so I'm gonna explain to you all what we have learned so far, okay. So first of all, we learn the condition for coplanarity, condition for collinearity, okay. If the vectors are collinear, okay, if vectors are collinear, if the vectors are collinear, now consider that I have position vector a bar, position vector b bar. If these two vectors are collinear, then we write first position vector can be scalar multiple of a second position vector, okay. This condition is very much important here. After that, we learn linear combination of a different position vector with respect to another position vector. Like I explained here, C bar can be written as x into a bar plus y into b bar plus z into p bar plus so on, okay. This is the linear combination for our vector. So in order to find out the values, okay, of our variable x, y, z. So for finding the values of x, y, z, we already have explained here. the Cramer's rule for finding the value of x, y, z, which is from the determinant. Now see that mathematics is the subject like that we have to use concept from different another chapter. Okay, in our vector chapter we have to use the concept from the determinant matrix. Sometimes we have to use the concept from some another chapter. Okay, so mathematics is completely based, mathematical chapter, it is completely based on the concept of another chapters. Okay, that means you need to be a perfect in another chapter, okay, another concept, then you can proceed with the solution for these examples. Okay, I'm expecting that you all have understood my today's lecture. Nothing it is difficult here. Even after, if you found anything difficult, let me know in my comment section. Okay, I will come up with a similar video. So thank you everyone. Thank you for my today's lecture.